Okay, so in the interest of everyone's time, we'll go ahead and get started. Welcome everyone, my name is Chris Rayfield and I'd like to thank you for attending this week's webinar on mechanical engineering and design. This week's webinar will cover how we can make Inventor more efficient with some simple customizations. If you have customers that use other platforms, let's integrate their work into ours. We also want to put our assemblies to work for us, as well as look at electromechanical design. Along the way, we'll touch on the small things that can make a big difference in parts, assemblies, and drawings. In addition, we'll introduce the concept of technology consumption gap. Next week's session will cover quote, design, and drawing automation, so be sure and register for that. Today's presenter is Ryan Johnson from D3's technical team. You may have questions as we go through this session. At the end, we'll provide a means to get your questions answered. A brief word about D3. D3 is the top integrator for Autodesk manufacturing solutions, offering a wide range of services to help our customers design better and manufacture better. Some of those services at a glance include training, public, private, individual, and corporate training plans, technical support, in the form of phone, live chat, and email, mentoring from one-on-one general Q&A to project consulting, implementation of technologies, best practices, and consulting on workflow and business processes, and automation of engineering, design, and sales. So with that, I'd like to introduce our presenter, Ryan Johnson.
All right, thanks, Chris. Welcome everybody to this session on manufacturing, mechanical and engineering design. So Chris introduced you guys to the term consumption gap. We're going to take a look at that today. The book shown up there, Complexity Avalanche, talks about this consumption gap. It defines it as the difference between the potential value a product could provide to an end user compared to the value that it is actually providing today. So that's kind of what we're going to take a look at here. And in this book, J.B. Wood identifies this top curve as the addition of, features to technology and the growing complexity of technology in the recent years. And this relates not only to our world, to mechanical engineering and design, even to industries like cell phones, cars, TVs, the trend is the same. This lower curve, this is the trend of users to consume those features without assistance. So the software gets better, we keep doing things the same way. So D3's goal here is to be able to help you maximize the value of the software that you already currently own today and minimize that consumption gap. So we're going to take a look at some workflows and tools that we see in this area that are either underutilized or not being used at all. Some of these are new to the 2016 software. Some of them have been around a while. We're going to take a look at simple customization through iLogic, assembly improvements, looking at the constraining tools, MultiCAD design environments, sketch different assemblies, and electromechanical design. So with that little intro, I'm actually going to jump straight over into Inventor, and we're going to get started. So the first topic we're going to take a look at is this part file right here. We have a flanged collar, and I'm going to go ahead and open a new drawing and place some base views of this part into the new drawing. So if you haven't used 2016 yet, we've improved the interface here. Let me make sure my tangent edges are on, and I'm going to go ahead and create these views. Now you notice down here in the title block, no information is there. Now I happen to have this title block set up to pull in information from the part file, title and description and part number and things like that. You may not set up your title block like this, but we definitely use the I properties for our parts in other areas. Maybe a parts list that we throw on the drawing. It's going to be pulling all of its data out of those I properties. And if I go ahead and look at the I properties for this part file, I'll notice they are indeed blank. So there, with some some very simple customization, we can actually have this file tell us when the parameters are missing. So if you noticed, I went up there and hit save, and immediately it's going to tell me fix those parameters. And it's going to pull up a simplified dialog box that indicates the parameters I use. So this is all done using iLogic. We're going to take a look at the code really quickly here. If I go to the Manage tab and turn on my iLogic browser, let's take a look at what we have here. First thing that we need to do is build the form. I've called it D3 Design Properties. And if we look at that form, these are very easy to build. Basically, we just pull anything we want from a list over here and drop it in the other half. So I've also added labels and stuff from the toolbox over here. Let's go ahead and just add one more. Maybe we want to throw the engineer into our optional category. So you'll notice immediately it shows up in the dialog box. I'm going to just click on the form button here to pull up that form at any time in the future. Now once we have the form built, basically we need to create a simple rule that pulls up the form. So I'm going to edit this rule and go ahead and take a look at it. Now you don't have to know coding to be able to build simple iLogic. Everything is here that you need. We have basically an if-then statement that we want to build. So here's the form finished. I'm actually going to comment, I'm going to make this not active, comment it out so that we can take a look at how it was built. Basically an if-then statement. What do we want to check? We want, if the parameter, or the I properties are blank, then we want to pull up a warning dialog. So this is very easy to do. All I need to do is double click on the property that I want to check. And I want to check a condition. So if it equals blank, like no text, right? Then we're going to tell it what to do. So on the then line, we have some other properties some other snippets we can use. There's a message box area here. I like to use the wizard over here also for message box. It makes it very easy to build. So I'm just going to say this is the I property. Check. We want a warning system sound, and we want it to give us this text. So without even knowing how to code, I'm just going to hit OK here. Actually, let's preview it first. There's our dialog box, and I'm going to hit OK. And Inventor will write all this code for me. So basically, if I run this rule now, if this I property is blank, the box runs. Now, you'll notice on the other rule, I added some additional stuff. We also want to show the iLogic form. So all I need to do is tell it what form to show after that dialog box, and it will automatically pull up my form. Let me save the rule and go to my form. I'm going to get its name, which is right here, copy it, and replace it with this. So now once I hit OK, the form pops up for me. Alright, so pretty easy code there, and again, I didn't have to know any of the code. I'm just using what's already there, which is great. You'll notice also my final rule is slightly different from this. I want to check not only the part number, but the title and the description. So all I did was add some ORs in there. We're going to check for if any of these is blank, then we would run our code. So let's go ahead and fill it out. With some information. And I'm going to leave the rest of these blank. We'll just go ahead and hit done. You'll notice now when I hit save, no more error. One last thing that we did in the background, the event triggers. We told Inventor before saving the document, we want to run the rule that we just wrote. And that way, every time a user hits the save button, the rule runs. And you'll notice now my drawing is filled out properly. So this would be very easy code to write, implement into your template file, and then automatically everybody's going to have this functionality added to their Inventor. Again, a tool that you guys already have today that's been in Inventor for several years. All right, I'm going to move on to the next topic, and we're actually going to be talking about the assembly joints. Now, the joints actually have been in Inventor since 2014, and I'm one of the people that really didn't use them for a long time because I was used to how the constraints worked. Joints are actually very useful for creating some pretty neat connection types. So I'm going to just go ahead and start with the joint tool and start putting this together. The first thing you'll notice about the joint tool is the selection is way different from the regular constraint. Basically, every face has multiple points we can select. Every edge also has multiple points. So when selecting something for the joint tool, you don't actually point to the point you're trying to pick with your cursor because you'll switch to an edge instead of a face selection. Basically, I'm just going to grab the middle of this circle and we'll attach it to the middle of this circle. Inventor does give us a nice preview. Now in this case, the alignment's wrong. I'm just going to flip it there. And we'll click the plus because we want to continue adding constraints. It's going to warn me here that we might need to change the alignment. I'm going to go ahead and continue adding the joint. We'll see it actually evaluates properly. So the great thing about the joint tool, one of the great things is that we don't have to tell it which type of constraint we want to add. It tries to decide based on the selections we've made. Now here's where it can really help. I need these bushings to be centered in these pockets. With traditional constraints, we could not do that with a single, 2 clicks. But with the joints, we can actually pick the middle of the cylindrical center point. And this is actually the wrong type it's picked. I'm just going to tell it I want a rotational. We'll go ahead and do that for the opposite one as well. And now if I check out my assembly, that's perfectly centered right there. So very easy to do. Another one I'll use it for is to go ahead and place this piece down in the base. Now this one's a little different. You notice that the cylinder doesn't go all the way through the part, so I can't pick the center of the cylinder. But in the right-click menu for the joint tool, we have some interesting options. We have an offset and we have a between two faces. So I can actually pick the two outside faces and grab the middle point between those. In this case, I could have actually picked the inside cylinder, but it's much easier to just do it from the outside. And again, to place it in the base, I don't have a cylinder through the middle, but I can choose the between two faces and center it right there. All right. Going to do a few more. I'm going to go ahead and place this piece, blue piece on the red piece. In this case, it's aligned properly. It's chosen a rigid joint. I'm going to go ahead and place this clevis on the end. It's also very easy to adjust the alignment if the software does it improperly. In this case, I want my yoke, the arm, rotated 90 degrees. So all I have to do is pick the alignment option, click another face, and basically what face I want it to be parallel with, and it rotates it accordingly. So the joint tools are great even for regular assembling. Of course, the joint tools also allow us, to automatically translate them for dynamic simulation without having to recreate anything. But even if you're not doing dynamic simulation, definitely can get some time savings and accuracy improvements with the joint tool. All right. Next thing we're going to talk about is MultiCAD design environments. So what I have here, actually, you'll notice in the browser, a new icon you may not have seen before. If I right-click and edit, you'll notice it's an import. We see it's actually a SolidWorks file directly inside of Inventor. So I did not convert the SolidWorks file to an Inventor file. I'm actually referencing the existing SolidWorks drawing. This is new in 2016. We call it AnyCAD. In fact, you'll notice in the Place rollout, we have Place Imported CAD Files option, and we can place any of these files directly into Inventor. Also maintaining the link to the source file. So I'm going to do a couple more things to this. Let's just go ahead and place a bearing. I've found one that matches with my auto drop. I'm going to go ahead and place this bearing here. So we'll just pick the location, and it'll generate the correct size. While I'm here, I'm also going to throw a little shaft in there in my design accelerator, so we have the shaft tool. And so let's go ahead and place that right in here. Pick an orientation. So if you're doing any kind of shaft design and you're not using this tool, this is great also. Very quick designs for every segment. All right, looks good. Okay, what we want to take a look at here is what happens if the source model changes. So what I'm actually going to do is go out to my workspace here, and I've actually saved two versions of the same file. Right now we're using version 1, so I'm going to copy and replace with a new version of the same file. You'll notice immediately in the background, Inventor recognizes that this file is no longer up to date and asks me to do an update, and it updates the file. Assembly constraints retained. It's not a new file, it's the same file that's been updated. Of course, I can go in now and make some adjustments to the length of my bolts or whatever I need to do for the new changes. So it's pretty awesome to be able to work with that design data directly, even though it's not Inventor data. And I want to look at one more thing with this. We can also open these files directly. So if I go to this assembly file, let's look for all files. We have an entire tooling table assembly. And we are going to do a reference model, not convert it. If we load the model, we actually even have the ability to tell Inventor which parts of this file we would like to work with. So I'm going to go ahead and only enable the cage, the frame, and the plate. I don't need all these toggle clamps and blocks, so I don't need to load those into the Inventor assembly. Again, we have an AnyCAD assembly directly inside of Inventor now that we can work with. Maybe even build some of those other detailed pieces on our own. So place imported CAD files also in the open dialog. If you just go directly to another format, we can now load them instead of importing them as we used to. All right, so let's jump on to our next topic. This is going to be sketch-driven assemblies. And so what I thought I would take a look at here is actually starting with a single sketch to define multiple pieces. So you guys probably know what this is. I have a model of a 3D mouse here, one of these pucks that we sit on our desk to navigate with. I'm actually using one right now as I'm looking at this. But you can see from this design, multiple components, but they all follow the same curve, the same shape. So rather than designing them individually, if I actually open one of these components, you'll see it's got lots of details, but if we look in the browser, it started with a derived part. So the base component behind that entire assembly is this file, and you'll notice it is a multi-body file. So it all started with one single revolution sketch. Afterwards, it was split into pieces, and it allows us to, with the single sketch, maintain that fluid design through all the pieces. So I'm going to actually open a blank one. Start with a revolution, and I'm going to start out by just doing some splits and dividing up to a multi-body. So we're going to go ahead and split. We're going to pick the split solid option. And we'll do this a few more times. This allows us to turn it into a multi-body from the single part that it began as. And so now you'll see we have multiple solids. I'm actually going to rename them. So this is the cap. We have the grip, the button base. We have an LED ring and a metal base. I can even grab these and start giving them their own colors. So it makes it a lot easier to work with in the multi-body. We'll make those two glossy. We'll make the grip a rubber. LEDs, we'll make them a blue color. And then the base we'll just go ahead and make polished. All right, so how do we get from this to an assembly? Right now it's a multi-body part. This is a tool that's been around for a while too. Very useful for designs such as this. If we go over to the Manage tab, we have a tool that is called Make Components. Basically, all we have to do is select the components we would like to turn into part files, define the name of a new assembly, and where we would like it to be created. In fact, here I'm going to create a new assembly actually in my mechanical design folder. In the next dialog, we have the ability to rename the components. So it starts with the name of your solid bodies. That's why I find it useful to name my solid bodies. But we could also rename it here in this dialog. We can also change the path that we're saving these to. And hit OK. And we've actually got a brand new assembly. You'll notice instead of traditional constraints, these are all grounded. So I'm going to jump to my other finished assembly first. And take a look at this same way that this one is built. I'm going to jump to this source part and go ahead and make a change. The benefit of, one of the benefits of building it like this is everything's defined off of this base part. So, for example, let's say this button. Let's go ahead and do a direct edit. If I'm looking at my 3D mouse, the buttons are actually bumped out a little bit, so we'll pick solids, we'll grab that, and we'll just drag it out this way a little bit. Another thing that I want to do, I actually have a sketch in here for a USB Type-C connection. And I'm going to pick a through all, cut through this solid. USB Type-C has not been released yet, but assuming pretty soon they'll be needing to build this. Because they have rechargeable 3D mice now. I'm going to jump back to the assembly that I derived from these parts, and you'll notice it also needs to update. So without having to redo any constraints or anything, when I hit the update button, the components are all updated to their state in the original part file. Now, in addition to modifying them from the original file, we can also modify on their own. For example, if we look at this grip, we'll notice that it's just hollow in the skeleton file. But if I open it in the assembly or in its own window, you'll notice that I've actually got downstream modeling features that I added after the fact inside of that. So it's just one of the many ways there is to work with sketch-driven assemblies. And anytime you have a design where you have multiple parts that need to be driven by the same parameters, this is definitely a great way to accomplish that. With the Make Components tool in the Manage tab, it makes it very easy to build that assembly and maintain all the links as you need to between all the part files. So we'll go ahead and close these guys down. Hopefully that is a tool you guys can take advantage of if you're not already. And I'm just going to throw in there in the assembly, we also have the ability to create and to make layout parts. So these are other great ways to do sketch-driven assemblies, maybe for something like the frame generator, to simplify that whole process. All right. So we have one other topic here. This is electromechanical design. You may have heard that Inventor now has access to the electrical catalog database, the same one that AutoCAD Electrical uses. So if you're doing electrical design in AutoCAD Electrical and Inventor, you know you can already pull electrical schematics into your Inventor wire harness environment to auto wire, as long as your connectors are set up properly with the correct reference designators and everything like that. The new tool is actually, again, in this place dialog, we have the electrical catalog browser. So I'm going to click on that. Now this is a window that can just float on your screen, your second monitor, or wherever. I'm going to go ahead and dock it to the edge beside my browser. All right, and basically we have all the basic component codes from electrical. So scenario here, I've got to design a box to put all this stuff in that my design is using. Now I know the codes of everything that I need to place in here. So this is looking directly at my database. I'm going to go to power supplies. No. I'll go to drives. All right, let's clear out this search and let's just see everything. And you'll notice huge library of all kinds of stuff. Now you're probably not going to use all of these. I like the ability to add stuff to the favorites. So if I look at my favorites list, you'll notice I've actually added something already to my favorites. If I click on this, I have some options here basically. And this one right here is actually going to add an Inventor assembly file directly into my model based off of this code. So I'll go ahead and place it. First thing I noticed is that my initial estimate was way off. Need to make this box a lot bigger if this thing has to go inside of it. We know we also need a few buttons, so I'm going to go to my push buttons, favorites, and I've added a green and a red push button. So again, we have the ability to add the file directly. We need 2 of these and 1 of these. I might also mention I got these directly through links from Inventor as well. I did not model any of these. If you go to the Autodesk 360 tab, we actually have a supplier content button right above the idea station. I hope you guys are already using. If we go to the supplier content, basically gives us 3 sources where suppliers can actually have uploaded their native Inventor files for you to use. So I'm going to go to Part Solutions here, and this is actually where I got the ones that I'm using here today. We have all kinds of components. I've got some ABB, some Phoenix Contact, all kinds of stuff. Now once we've downloaded the files, what I'm going to do, I actually need a selector switch to be added to this. So I'm going to jump over to, let's take the favorites off, to the selector switches. And I do not have any favorites in selector switches. So I'm going to erase this. I actually know that I know the number of what I need to add, so actually that is what I'm going to search. So we want a 10B. It's actually the very top one right here. Let's do one more. And then the 4, let's go to a clear one on the 2. Alright, so I'm looking for 11C, which is the one I want to add here. You'll notice this time I don't have a file listed already. I'm going to go ahead and click this Browse button. This lets us browse for a part or an assembly that we want to be related to this line. So if I go into my electromech folder here, we have the clear. And I'll go ahead and just select that assembly file and hit open. Now it will say this is not in the library paths. We go ahead and place it, and you'll notice the file is actually added to, I think I clicked something wrong there. Let's go to our folders and look at what happens. So I've made electrical components my library for the electrical components. As I add them, it actually adds the file for each component. So we'll then use that file the next time. And once you've mapped it once, you don't ever have to map it again. The first selector switch that I started to throw up there, I was going to map with you guys, but I did it right before this presentation, so it was already in my library. All right, so that is the electrical mechanical design, the ability to link directly to that electrical catalog browser and use actually the same items, have them linked to 3D models in Inventor. You'll be sure you're using the right components instead of building your own separated from the catalog. All right, so that was the last little topic we were going to cover on the mechanical engineering. Hopefully you guys saw some stuff in there that you can use today. Again, our goal was to tighten that consumption gap. So definitely all of that stuff is available with what you're using right now. If there's anything we can do to help you use those better, definitely let us know. So with that, I'm going to kick it back over to Chris.
Thanks, Ryan, for that very informative presentation. At this time, I'd like to provide 2 brief polling questions. So we'll put the first one up.
All right, poll is up.
There we go. Give everybody a minute to click through that. And let's go ahead and put the second one up.
All right, I'm going to close that. You guys should see the second one.
Hope everybody will check out our website. It's d3tech.net for more information on upcoming events and the calendar for the upcoming D3 Virtual University Series sessions. And it looks like everybody's completed that. So thank you for all your time and attendance today, and we look forward to seeing you at our next D3 Virtual University session. Thanks, everyone.